Hello, welcome. So in this series, we're incrementally building a C compiler using data-oriented design. And so far, we've gotten to the point where we're starting to implement an abstract syntax tree. And we need to get this dump method working. So we need to get pretty printing of the abstract syntax tree working. So that's the goal for today, and hopefully maybe a little bit of parsing as well. I guess we'll see. So one thing that I wanted to talk about is that this series is going a little bit slower than I would like. Part of the issue is I'd like to keep episodes under 40 minutes because then at 2x speed, which you should be watching at 2x speed if you can, that's what it's optimized for. Yeah, it just makes it about 20 minutes. The issue then is if I'm going line by line and talking about each line as I'm writing it, that's going to take a very long time to build a compiler. Especially if I want to do like an SSA backend with register allocation and all of the rest, it's just going to take a very, very long time. So I think we need to pick up the pace somehow. And my idea for picking up the pace is to talk less while I'm programming, maybe speed up the programming sections a little bit more, and then do kind of a code review of each section when I've completed it. Or if I find a bug or some frustration, maybe bring you in to talk about it then. So I think that'll speed things up a little bit. I've also messed around with my audio settings to kind of just make the editing process a little bit less laborious for me. Let me know if it just sounds really off or weird or something. I'll check the comments. The other thing is I got rid of the blinking cursor, so hopefully that doesn't mess with my auto editing scripts because it was before. So the blinking cursor was preventing it from speeding through some sections, which is annoying. So now it's not blinking, so hopefully that'll fix that. So without further ado, let's get into things. I did make a small change here. I added Gauzy here, hoping that it would help with some of the indexing. I mean, it should be in here anyway. The header file, we want it to recompile if the header file changes. So there's that. What else? So another thing is we're going to be doing a bunch of string building with the dump method here, and just with the C standard library, it's a little bit tedious to do that. So I'm going to bring in a little bit of a helper function here. So there's probably some headers that need to be added, probably. And then I think, so what is this? Well, it's from here, and I think it was originally borrowed from Plan 9. But it is an SE printf, and I think this starts for start. I think this stands for start end printf, and you can pass in an end pointer instead of the number of characters. So you can calculate this just by taking the max size and then calculating the end pointer. But the nice thing about this is it returns the character pointer where the next thing can be appended to the string. So it just makes things a little bit simpler. And I've split this out into one that takes a variable number of arguments and one that takes a VA list. And the VA list one can be used elsewhere to kind of make more printf-like things. And then this attribute here, I believe, will make it check the printf variables to make sure they align with the types of the parameters. I believe that's what it does. I don't know if this is portable, but we can fix it later if it's not portable. I think that's everything here. So that will just make building this dump method a lot easier. But I really like this method of just passing the pointer back and doing it that way. So I think I'm going to change I think there was something that gets the string in the tokenizer. I think it was token string. I think. Yeah, I'm going to change token string to do the same thing. So then it would take a buffer and so it takes a buffer and an end. And then in the code, we need to change it. I actually don't think you need this. So seprintf will return the end pointer if it reaches the end. And so I don't think I need to worry about it writing past the end. It should just stop at that point. So this should be safe. So yeah, seprintf like really simplifies appending to strings, which is perfect. That's exactly what I want. And then I wonder if this broke anything anywhere. Yeah, I'm just using token string no nil here. So I think the other one's not used yet. Perfect. Is that the only warning? Just tell the compiler to, yeah, I know, sort of thing. Still thinks it's unused even though it is used. I'll worry about that later. Okay, so we need AST dump. So let me work on that. I'll get back to you in a second. Okay, so I have it dumping literal 42. This seprintf really helps a lot. Had to struggle with the autocomplete a little bit though, because it wanted to use the standard library instead. I really wish. Well, actually, I'm using GitHub Copilot now. So Copilot also has issues with reading header files. That's super annoying. You'd think that would be something they would test. Anyway, and this is not true because it can find it. So yeah, the linter is just a little bit behind. I'm not sure how to kick the linter other than reloading the whole window. Okay, so we've got it taking the current node and printing the node string. I added the node type as a string here. And this is a nice C syntax. I think it's like C99 or something like that, where you can put in like the enum and assign it a string that way. That's kind of nice. So we've got the type being converted into a string. And then if the node type is a literal, then it's dumping the entire token string into there, and then it's finishing up. So that should produce this, and it seems to because the tests pass. So the other thing I had to do was add the same thing here, but for tokens. And for tokens, I needed to put it here. And this will be handy for the binary nodes, because then we can put this text into the binary nodes, which we'll get to in just a second. And then I added this function here to return that, and added that into the header file. Then there is the tests. I just got the end of the buffer, and that's one before the end. And size of is just getting 1024 here. Yeah, see, it says it's 1024. So I'm getting the end pointer, and I think these parameters probably need to go in the beginning, like at the front of this. But if I wanted to dump multiple nodes, I could then do so quite easily using this syntax. So I think it's a good win. And this is the output that we get, and this test passes. So now I'm going to add in binary nodes and get that working. Okay, so I'm trying to come up with the iterator. So I was thinking doing something like this where we've got a node iterator struct. It's just a value struct. So iterating backwards through the list would just return the node iterator. And then there's a way to get the node out of the iterator here. I don't really like this. So the way that we find the children of a node is each node has a number of subnodes. And so we skip over the number of subnodes for each child, and then that goes to the previous sibling, basically. So this is the way of getting siblings. Let's see if I can come up with a better way, because I don't like this. It's not working. I wonder if we even need an iterator. Let's try without even an iterator, and we'll just go with finding the next sibling of a node. No, that's a dead end too. It's not going to work because here. So this isn't the first child. This is when all of the children have been kind of skipped over. So this will be a child of some other node because the children come first in the array. So yeah, it's just not going to work. I think we need an iterator. And I think in the iterator, we need to keep track of how many subnodes are left. Maybe. Yeah, let's try that. So this is also a dead end. Okay, I think this works. So we've got a child iterator. It's iterating over the the children of a node, we can get the iterator, and it just returns an iterator initialized with the number of subnodes of the node and the first child of the node, which is always one position to the left. And then we've got a previous child, which if there's no more subnodes left, it just returns no node, which is a special value just indicating that there's no more nodes left. And then we've got a number of nodes for the current child. We remove those from the subnodes that are left, and then we move that many nodes to the left, and that should be the previous child. And we're starting from the end of the list and going back to the beginning of the list, because the children are added to the tree from the leftmost to the rightmost, but we're iterating from the rightmost to the leftmost, if that makes sense. So this will return the previous one, and then we need to flip it around somehow. Unless we can parse in the opposite order somehow, and then this would be the next child. I don't know how to do that. So let's not worry about that right now. So now we've got a way of iterating over the children. For the literal node, there will be no children, so you don't have to worry about that one. So we need to flip the children around. So we'll need, we need a dynamic array here, I think. That's annoying. Okay, so I think I have this mostly implemented. I'll just go over what I did so far. So here we've got, okay, I didn't fix this. I'll have to fix it. Okay, so let's see. We've got this that it's trying to produce, and it's all on one line. So we emit the node type string, so that's this part here. Then we're checking if it's a literal. If it's a literal, then we just do the token string. So that would be this part right here, but it's not a literal, it's a binary. So we do the token type string, which will be this add right here, and then a comma space afterwards. And then we need to iterate over the children, but the children will be backwards from what we need. So unfortunately, we don't know how many children there'll be, or even what the maximum number of children will be, because this could be an entire file. So it would be everything in the whole file, or it could be a code block, which would be a lot of statements. So unfortunately, we have to malloc. And then we want to keep track of the capacity for how much we have malloced. And then we iterate over the children. We have to iterate over the children backwards. And I might do some thinking to see if there's a way that we could iterate forwards somehow. I don't think there is, but there might be. Yeah, no, there's no easy way of knowing, because we'd have to scan all of the children until we find one that matches up with the number of subnodes, which I guess we could do. It would save this allocation. Yeah. Yeah, that's a thought for another time. It might be possible to go forwards, and then it would save these allocations, which are slow. So even if the forwards movement is slow, it would be faster than the malloc, probably. Anyway, I'll come back to that at a separate time. So we've got the previous child, and we're just using the iterator that we just built. This is wrong. I don't really like that. Yeah, we'll have to figure that out at some other time, I guess. So we get the iterator's first node. We go until there's no node. We get the previous child, and then we check if the number of children is at capacity. If it is, then we double the capacity. We have to do this rigmarole with realloc because it could return null, which is annoying. So we have to deal with that. And then we have the number of children, or we have the child list, and we put the child in there temporarily, increment the number of children. So then we've got our list of children. Then we do this funky business where we figure out, okay, do we have more than 3 children, or more than 2 children, really? If so, then we do a new line and leave the indent alone. Otherwise, we zero out the indent so it won't add any indentation, and we'll just put the children in line. And we're not actually handling indentation yet, but I want a test case that kind of tests that first before we implement that code. So then we've got the children array. We iterate over it. And we're iterating over it backwards. That's not what I want to do. Yeah, that's right. Okay, and then we dump each child with a proper indentation. If we do indent, then we add a new line. Otherwise, we put a space. And I think that's everything. Then we free the children that we accumulated, and we put the last remaining bracket on there. So I think that does not work. So what are we getting? We're getting the expected and these are backwards. What are we getting here? We're getting literal 5, literal plus binary int. It's not correct. So we're just getting a bunch of gibberish. But it's starting with literal, so that's not right at all. So I'm going to do a bit of debugging, and I'll get back to you once I figure out what that bug is. And I think this is what the bug is. We're putting so the way that nodes that have children work when we're creating them is we call start node at the beginning, and then we call end node at the end, and the children go in between the start node and the end node calls. But we're allocating the start node first, and that's not correct because the children come first and then the parent in the list. So this allocation actually has to happen in the end node method instead. So let's see here. I just had a thought, or do we want to actually fix this? Because maybe this fixes our problem of having the AST stored backwards. Let's try a different fix. Let's just leave these the way they were, and let's try a different fix. Mm. There, finally, we've got passing test cases. All right, let's go through the code. So I had to add a few iterators here, or a few functions. Mainly this. I refactored the iterators so they go over the next children. So yeah, now we have this array. If I go into here, this nodes array is in the proper order now. So the root is at the beginning and the leaves are at the end. So that's how I originally wanted to make it, and I thought I couldn't for some reason. And now I'm wondering why I thought I couldn't if I just subconsciously accidentally made it work. So I don't know. Anyway, I guess some part of me thought it wouldn't work, and some part of me was, well, here's what the solution is. I do programming mostly subconsciously, I guess is the way to put it. Like, I've been programming for so long that it's just automatic, kind of like walking is automatic for me now. So I guess the right side of my brain, or whatever it is, knew the correct solution to the problem. And I thought it was another solution in my language part of my brain, I guess, my left side. Okay, so I don't know how all of that stuff works. That's just my guess. Okay, so this test passes. I'm just manually parsing for now, just by grabbing the next token and building the nodes manually, and then just checking if it equals this. In the AST, we've got the iterator. The iterator is now the other way around. This creates a new iterator. I guess actually maybe a better name would be new child iterator. This gets the current child from the iterator. I mean, we can just get that by going iter.node. So this function is not totally necessary, but and then we've got the next child. This takes the iterator and returns a modified iterator. If there's no nodes left, it just returns the same iterator, and then that's handled right here when you try and get the node. And then you've got the number of subnodes, including the node itself. So you have to add one. And then there's a modification of the number of subnodes left by subtracting that. And then we increment node by the same amount and return it. Could probably reduce the number of variables somehow, but I don't know exactly how. Yeah, not sure how. Then we've got has next child, and this just returns true if the next time this will be called, there'll be no subnodes left. So could probably simplify this iterator a little bit more. I think I'll have to think about that some more. Because right now it's really awkward to use. This is what you've got to do in order to use it. I don't really like that. I feel like this could be simplified. So I'll think about that a little bit more and see if I can simplify this. But yeah, so when we're generating the dump, we just go through, I think we mainly covered this except for the skip comma. This is just, doing the formatting properly. And if it's a binary node, then we've got this extra token that we're adding on that indicates which binary node it is, which we could probably simplify by making the type more explicit. It simplifies some things and makes other things more complex. So I don't know. Another thing I need to think about a little bit more. And then we've got the AST dump. Yeah, so we're iterating over each child, and now it's in the proper order. So I removed the malloc and realloc thing to reverse the order of things because that's not necessary anymore. Thank goodness. So then we're dumping the child here. And then if we're skipping the comma, or if we're not skipping the comma, then and there is another child, then we write out a comma. Otherwise, we set this so that it won't skip more than once. It just skips the first one. And then we check if we're indenting. If so, then we new line. Otherwise, we check again if there is another child. So we could probably make this a little faster by just doing this once, but whatever, it's a cheap operation. It'll probably get inlined anyway. And then the compiler can figure out that this is the same and nothing's changed, hopefully. And then we add a space if there's more children. Yeah, so then there'll be a space between children, and then we put our final thing here. And we haven't handled indentation yet, but this works. So we're getting the correct result. So awesome there. Now we need to figure out indentation somehow. So I guess we need a test for that. There we go. It's passing. So in the test, I did a bunch of code to parse it so that the tree looks like this. It's a binary node with a literal as the first child, and then another binary node as the second child, and then the literals 5 and 7 as children of that one. So this is an add and this is a subtract. So I got that working, and then had the dump handle the indentation properly. So there's just a print indent function that indents properly according to the indent level. And then we've got, guess we don't need this anymore. And then we've got, it printing the indent as the first thing it does. So before the name of the AST node, it prints the indent, and then it's checking here if the next indent. Oh yeah, and I moved this code up here. So this code is the code that's checking if there's more than 3 subnodes, then or if there's less than 3 subnodes. So if there's only 2 subnodes, then it will just put them in line like this. Well, this is the signal that it'll just put them in line. So this removes the indentation, and then when it prints them, they won't be indented. And then here we're putting in the token type string after the first parentheses, and I want to keep it on that line. So here's just checking if we're indenting. If not, then put a space there. Otherwise, if we are indenting, then there'll be a new line inserted there after that. And then here we're just going through the children, dumping each child. So then we're dumping the node, which will indent it if necessary. We're putting in the comma if necessary. And then if we're indenting, then it puts in a new line. Otherwise, if there's more children, it puts in a space. And then we want to indent the closing bracket afterwards if we're indenting. And that seems to work. So I think that's everything. Yeah, let me know if you like this new format where I just kind of do a code review after I do a bunch of changes. And then we just speed through the actual coding part. I don't know if that'll work out. Maybe I'll put a poll on the community page, and I'll put a link to the poll in the description of this video. And you can let me know if you think this is a good format or not, or if I should go back to the old format. Yeah, so thank you very much for supporting the channel. If you do, I very much appreciate it. And thank you very much for watching. That's certainly much appreciated as well. So I hope you have a great day. Thank you very much. Bye.